Good day, students. In this session, we are going to learn about coordinate measuring machine. So, what is meant by coordinate measuring machine? So, so far we have learned many measuring equipments. In this measuring equipments, so mostly they are some two-dimensional, mostly two-dimensional. So whether they will measure in either in x-axis or y-axis, either in any one of the axis they will concentrate, and their limitations are very low and very specific, and they cannot be automated. So manual intervention is very important, but due to some higher production rates, we need to increase the quality checking, and to improve the quality checking, and also to reproducibility of the components, so that with the complex geometries we need to take the dimension of the complex geometries. So the, when the geometries are very complex, the conventional measuring instruments are invalid to take the dimensions, especially for curvature related structures. So therefore, the concept of coordinate measuring machine has been developed and effectively used in all industries, almost all industries, for their quality checking and product development. Let us see about the coordinate measuring machine. So overview. So the coordinate measuring machine are extremely powerful metrological instrument that I have already explained. It's a device for measuring the physical and geometric characteristics. So it will measure the physical characteristics, but mostly uh, the important aim of the CMM is to measure the geometrical profile and measure the geometrical dimensions. So automatically it will mostly the complex structures, complex shapes can be easily able to measure using this CMM, right? Now what you can see is the huge sizes of CMM. You can see here. This is gantry type of CMM, and you can see these are the structure. And in the structure, you can see this is the measuring head, and from this measuring head, and this measuring probe holder is there. Under the measuring probe will be there, and you can see this structure. And now, if you want to reproduce this structure, or you want to ensure the asset component profile each and every, because, for example, in aerospace and aeronautical, the wing structure and fuselage structures are very complex, contains many high-end curvatures. So to measure these high-end curvatures and dimensions and ensure the dimensions of high-end curvatures, it is very challenging with the conventional tools. So here they are using, and by tracing the profile, they can very easily can able to measure it, and the profile, what to say, they can very easily be able to measure it, the dimensions. And this is the laboratory scale or industrial, another industrial limitation depends upon the product sizes. These structures will vary. This is the common type of CMM, and it will move in z axis and x axis and y axis, and this is the bridge. Over this bridge like structure, that the measuring head will be placed, and at the end of this measuring head, that the measuring probe will be placed, and on this table we will place that workpiece. Okay, and mostly this whole bridge will move in y-axis from to and fro, and this measuring head will saddle like what they mentioned saddle. They will move in left and right direction in x-axis, and this it also will this whole is this setup will move up and down in the z-axis. So this is the real setup. What you have seen here is the line sketch, and you can see this real equipment. So where we can use this CMM, so in aerospace, in automotive, food processing, healthcare, paper industries, pharmaceuticals, plastics, research and development, and semiconductors. So these are the wide areas we can use these coordinate measuring machines. So the differences, what is the differences between the conventional metrology and coordinate metrology? So in conventional metrology, the manual time-consuming process. Mostly the conventional metrology is a time-consuming process because of high manual usage, and here the alignment of test piece is not necessary. Well, just you have to keep it with your workpiece or component on the table, and you can trace it from anywhere. So you can trace the profile. It is very easy. So that is the kind of setuping time, and some other procedures are cannot. It's not a problem. They can be easily solved here. And this is single purpose and multi-point measuring instruments make it hard to adopt. So multi-point measuring instruments. So if you want to measure the profile at multiple positions and multiple coordinates, this is very difficult with conventional metrology. But it is possible with the coordinate metrology, and that I have told you, very accurate and curvatures and complex structures can be easily measured with this coordinate methodology, but it is very difficult and many limitations are available. Also in geometry, because it is this coordinate methodology is linked with mostly concentrate to measure the dimensions of the geometry, complex geometry. So the geometry measuring instruments like vertical caliper and angle protractors and speed gauges that are never able to measure never able to trace the geometry. They can measure the standard sizes, standard geometry like rectangle, circle, triangle, or like that. But some complex curvatures and spilines, like of curvatures, which are mostly involved in aerospace and aeronautical applications. So these tools are very difficult to apply. What is the curvature of some components present in the aeronautical application? Very, very difficult to use the vernier calipers and other things to measure their curvatures. But here, using the coordinate methodology, coordinate measuring machine, you can easily able to do it. So the basics of CMM has three axes. So at a time, it can measure in three group coordinate axes, X, Y, and Z directions. And mostly based upon the structure, we can divide this CMM into five. One is cantilever, another one is bridge type. Bridge means I will explain you. Get the structure. It's holding that bridge is a structure holding the measuring head, and which will move in. It will move or it will fix it with the structure. Okay, and column type and horizontal arm and gantry type. So this is the cantilever type of measuring machine. In this cantilever type of measuring machine, you can see the structure here. In this structure, these measuring edges dropping out like a cantilever beam, and from like a cantilever at the end of the cantilever beam, that is like this measuring head. That probe holder will be placed, and at the end of the probe holder, that probe will be attached. Most probably, the CMM also classified based upon the type of scanning. Type of scanning means contact type and non-contact type. Contact type means a tool or a probe will be used to touch the component and trace the profile of the component. And non-contact type mostly will use the laser or video scanning or white light interferometry principles to scan the profile. Both both can be adopted in every structure. Okay. Now we are dealing with the type of structures, cantilever type, right? So the vertical probe moves in the Z axis and carry a cantilever arm that moves in the Y axis. So this will move in Y axis. The total structure will move in Y axis, and these table, table measuring table will move in the X axis. So for some limited sizes, some compact size components can be easily be measured or traced with these cantilever type. So bridge type I already told you in the previous examples also, this is a bridge type actually. So the structure is called the bridge, and the structure will move in this in y direction, front and back in the y direction. And in this bridge, that measuring head will be attached, and this measuring head will move in this x direction and also in the z direction to make the to trace the 3D geometry. So most widely used of this pitch type will be, whether it's moving pitch type will be used. And another one is fixed bridge type. Sometimes the bridge is fixed and maybe the machine table will move in the y-axis or in the x-axis. So some depends upon the application, depends upon the component variation, it can be adopted. And column type, it is almost like a cantilever type, but the rigidity is very high. Accuracy and the rigidity is very high when compared to the cantilever type of CMO. So it's horizontal arm where this your structure is fixed at the table, and this horizontal arm will prop up and it will move up, come front and back, and it will measure the profile. Cantry type. Cantry type is very sophisticated type of CMM. In this, you can see the structure. The structure can be movable. Whole structure can be movable. Or maybe the structure is very huge, and you can even place a car or any other automobile bus like huge structure, huge products inside this gantry, and you can do the measurement by moving these heads. You can see the head here, and this head will move in the y-axis and this x-axis and z-axis. So whole measuring component will be placed inside it. So the size limitation is not a big deal in this gantry type. Now you can see here, this is the gantry type. You can see the huge structure, and inside a car is placed, and this car is the component here, the product here, and they are tracing the profile of the car and ensuring the aerodynamic geometry of the car, and they are measuring. So this is the advantage of gantry type. So these are the other types of many profiles are there based upon the applications, and the mode of operation. You can do the manual operation or manual or computer integrated operation, motorized operation, or directly computer controlled operation. These modes of operations are possible in the CMO. So in manual operation, manual intervention, a human labor will be employed, and he will do some, he will move the probe, and he will trace the profile through by his hand, and he will measure it. So the for this intervention of human intervention is very huge in the manual computer assisted what is it? The CMM, and motorized, mostly the joystick will be used, even human is involved, and using in the video game we will use many joysticks. I think if we control the joystick, they can move the these tool heads in the X and Y, then Z directions, and they can do the measurement. And direct computer control means like robots, like CNC machines. If you control it, if you given the if it is controlled by a robot, and this robot will automatically do the measurement. Okay, so these are the probes that I have already told. It can be contact type or non-contact type, and contact type can be touch and trigger probe or analog scanning probe, and in non-contact type use laser probes or video probes. So these are the different probes, right? So I will show you a video about the CMM, how the CMM will work, and you will be appreciate how this will work.
The CMMs are located in the metrology lab, downstairs in the Ross Engineering Building, room 139. Before you start, always make sure that the probe is clear of unwanted obstacles whenever measurements will be taken. The jog box diagram is located on the table next to the CMMs. To begin, open the air valve and power on the CMM controller. The air valve is located in the front of the CMM, and the switch for power is on the back side. Next, clear the e-stop by pulling and twisting the large red button on the jog box. Then press the machine start button. Log on to the computer closest to the CMM. Then open the PC Demus online software. For CMM1, use tip 1. For CMM2, use tip 2. Verify that obstacles are clear of the measurement probe. You may need to press machine start again if there is an error. Press OK. Select File, then New to create a new measurement program. Name your file accordingly, verify the unit is correct, and then press OK. In the Probe Utility dialog, select Tip 1 from the Probe File box, then select the tip in the active tip list. Press Measure. Ensure that MAN plus DCC, Calibrate Tips, and Default Mode are selected, then press Measure. Press Yes to measure all tips. Select Yes, Manual Hit to locate tool, then press OK. Select OK.
So they will explain that the machining setup before doing the measurement. Not a problem. Just watch how this measurement can be done. This is a touch type probe CMO.
OK to acknowledge the warning. Take a single probing point on the top of the calibration sphere located at the back corner of the CMM table. Press Done on the jog box to allow the CMM to complete calibration.
Now CMM is now you can see the reference point it is checking from this reference point. You can see a small a tip, a probing tip, a red color tip, and it is a LED. When it touches, it will glow, and it will ensure that measurement is happening.
Press Continue to finalize the tip calibration. Select View, then press Command Mode to change from Summary Mode. Resize the edit window so you can view all of the text. You are now ready to probe using 15 widely spaced hits.
Now you can see these probes. This is the probe, and this is the measuring tip. And by touching it and tracing it, we are measuring the geometry of this component.
Probe the top flat plane of the demo block. Then push Done on the jog box to identify the feature in the window.
See how they are uh, scanning this profile.
You can rename the measurement by double-clicking on plane A.
So you can see here.
create a line, take 3 hits on any flat surface. Then press Done. Line B will appear in the edit window. To create a point, use 1 hit on any surface, then press Done. A computer alignment must be created to position and fix the part in 3D space by eliminating all 6 degrees of freedom, translation in X, Y, and Z directions, and a rotation about each of these 3 axes. The 3 features created prior will be used to create an alignment ABC by identifying the appropriate feature for each of the following. Level, whichever feature constrains 2 of the 3 degrees of freedom, a 3D feature. Rotate, whichever feature.
So this is the way the CMM works. So in this class, we will see about other measuring instrument. Right. Thank you very much.